Hey, welcome to this tutorial about the counter mode in practice. So in the lecture we've seen the randomized counter mode. And in the randomized counter mode we basically initialize the counter with a random value and then start counting from there for all of the blocks that we want to encrypt. In practice, however, there's a different counter mode that also is applied pretty often, and this is the stateful counter mode, let's say. And there the idea is that both the encryptor and the decryptor, so the sender and the receiver, they both keep a counter. And they just initialize it with 0, which has the advantage that they don't have to communicate to agree on an initial counter value. It's always just 0. And then, like when you encrypt, then you just encrypt by PRFing the counter value, so by applying the PRF to the counter, then XORing that with the message, as usual, like as we also did for our randomized counter mode, and then you just increment the counter. And then the decryptor does the same. So if it receives the ith ciphertext, it would decrypt it by XORing it with the PRF value of I, so of the index of the message. And in practice, this pseudonym function is usually instantiated with AES. And yes, AES is a PRF. It's not actually an encryption scheme, although using it in some kind of counter mode or randomized counter mode will make it an encryption scheme. But if you, for example, try to compute AES in like Java or something and you don't specify any additional options, you will just get AES in the ECB mode. And then this will be an insecure thing, because if you just encrypt things by running it through a PRF, then this is deterministic encryption, and deterministic encryption is not a good idea. So my questions here are for you, I guess. Does this actually work, the stateful counter mode that is used in practice? So can we reasonably say that this is secure in some sense? And then the following up questions would be, if this kind of works, I mean, it's used in practice at least, so why didn't we define it like this in the lecture? Why did we do this randomized counter mode? Because the nice thing, if we just did it like here, would be that we would never run into collisions. So in the randomized counter mode, you may have this collision event that we analyzed in the proof. If that happens, then all of our encryptions may be insecure, or not all of them. Some of the encryptions may be insecure, the ones that have a collision. And so we had to analyze this event. And in the stateful CDR mode, there's just no way to collide for any of these values, because I just increment them all the time. And unless I'm actually encrypting more than 2 to the n values, then I will never encounter the same counter value twice. So, do you have answers for these? I will talk about my thoughts about them in a bit. So now, does this work? Yes. I mean, yes, of course it does work. If it didn't work, then people wouldn't use it. The only thing that you have to be careful about is a little bit of making sure that you decrypt stuff in the right order. So if I send 10 messages, then you have to receive those 10 messages in the exact same order, in order for you not to use the wrong PRF values in order to decrypt. But that's kind of a given. You can just use TCP for that, and then you're fine. Other than that, it actually does work pretty well. And it actually is also secure. The idea would be that we can prove this, if we had a security model where we had a stateful encryption scheme, then we would be able to prove this stateful encryption scheme in this model secure. The main argument would just be that if we replace, the argument is always, right? If we replace this pseudonym function with an actual random function, then whenever we give it a new unseen counter, it will just, this whole PRF value XOR n will look like a random value, because it is a random value. And then nobody can get any information about it. And then, because this works for the actually random function, the pseudonym function is indistinguishable from that, so also for the pseudonym function based scheme, the same should hold, at least for PPT bounded adversaries. So yes, it does work, and it is secure, at least in the CPA sense that we've seen so far, at least against passive adversaries. So what's the difference to the lecture, where we've already talked about this? This counter mode here starts at 0, and in the lecture all of the counters will start at random values. And then also in the stateful counter mode, there's only one counter that goes up between multiple encryptions. So the idea here in the stateful counter mode is essentially that I set up a key and then I have one communication partner with that key, and I just use this for as many messages over time as I want to, just incrementing the counter each time. And the lecture definition is somewhat more stateless. And this also plays into why did we define it like this in the lecture. And that's because in many times it works actually to replace state with just randomness. So the difference is that in the stateful mode, we have this state. We can just completely, perfectly make sure that we never use the same counter twice. But in the stateless scheme, we don't have such luxury. So if someone calls encrypt twice and it's stateless, then we can't just start both times with just the counter 0, because then we would have these collisions that we don't want. And to replace the state, like remembering which of these counters did we use before, we can just, like as a workaround, use randomness. And then just say, okay, I don't know which of these counters I've used before because I don't have any state. However, I can reasonably say that if I use a random counter, then it's pretty likely that I've never used this before. And then all of this kind of works in the way that we've proven it in the lecture. So yeah, the reason that we didn't define it is either, depending on how you want to look at it, it's either that you don't have state, so we can't otherwise make sure that we don't repeat counters. Or you can look at it in a way that says, if we look at this stateful counter mode and we just didn't use state for each invocation, but we actually ran this whole protocol up top here for every time we encrypt something. In that way, it wouldn't be CPA secure because we would start multiple encryptions with the same counter and then everything falls apart as we've seen before. Okay, that's already it for the counter mode in practice, just as a little bit of understanding why we did randomness in the counter mode in the lecture and how it's sometimes used in practice. Thanks for your attention and see you.